Dear students, in this lecture, we are going to discuss about pure resistor excited by AC supply. So, pure resistor excited by AC supply. This is the pure resistor which is excited by AC supply. Let us consider a alternating or sinusoidal AC voltage is applied across pure resistor is given by small v instantaneous voltage. Small v equals to Vm sin omega t, that can be also written as Vm at an angle 0 degrees. This is the reference signal Vm sin omega t. Sin omega t can be written as Vm at an angle 0 degrees. So the instantaneous value of voltage will be taken as Vm sin omega t across the pure resistor. Then the current flowing through the circuit will be taken as the instantaneous value of current will be the current flowing through the resistor is taken as I equals to, as we know, that V by R. Small v is nothing but Vm sin omega t divided by R. So here Vm by R is taken as a Im. Vm by R is nothing but Im. So the value of current will be maximum when during the first quarter of cycle. That means 90 degrees only. Sin omega t, sin 90 equals to 1. So I equals to Im sin omega t. Vm by R is taken as Im. So that finally we can conclude that there is no phase difference between the voltage signal and the current signal. This is the current signal. This is the voltage signal. Voltage signal is taken as Vm at an angle 0 degrees or Vm sin omega t. Current signal, initially we have applied the voltage signal across the pure resistor Vm sin omega t. Then we have derived the current signal I equals to Im sin omega t. This can be also written as Im at an angle 0 degrees. Im sin omega t. Sin omega t written as 0 degrees. So current signal is voltage signal is Vm at an angle 0 degrees. Current signal is Im at an angle 0 degrees. So finally we can conclude that from the above previous two equations we can conclude that there is no phase angle difference between the current signal as well as voltage signal. That means current is in phase with the voltage. In pure resistor there is no phase angle between the voltage and current. Here we can draw the power signal, voltage signal, current signal. So first initially we can draw the voltage signal. So this is the blue color signal indicates the voltage signal, always reference signal. Initially we have applied the voltage across pure resistor. So the voltage signal is taken as reference signal. So the waveform complete one cycle duration is 2 pi radians or 360 degrees. So as we know that already we have derived for pure resistor current is I equals to Im sin omega t. So Im sin omega t also written as 0 degrees. Im at an angle 0 degrees. So current signal is also starting at 0 degrees and terminating at 2 pi radians or 360 degrees. So during the positive half cycle, the power signal will be, this is the positive signal 0 to pi, voltage signal will be positive as well as current signal is also positive. Positive into positive, positive only. So power magnitude will be higher. Current voltage into current. Similarly, during the next half cycle, the voltage signal will be negative and as well as current signal is also negative. Negative into negative, so positive. So minus into minus will be positive, so that power signal will be positive. So in this way we can draw the voltage signal as well as current signal and power signal. Next, as we know that we can also derive the instantaneous power. As we know that instantaneous power P equals to V into I, small letters. Instantaneous values are always represented by small alphabets only. So small p equals to V into I. So P equals to, as we applied voltage Vm sin omega t, I equals to, we have derived signal across the resistor, current flowing through the resistor Im sin omega t. So Vm into Im sin square omega t. So here we can multiply the 2 and divided by the 2. So that Vm Im by 2 into sin square theta. So 2 into sin square theta. So Vm by 2, Im by 2 can be written as Vm by root 2, 2 can be written as root 2 into root 2. So Vm by root 2, Im by root 2. Sin square theta can be written as 1 minus cos 2 theta. 1 minus cos 2 theta. So that P equals to Vm by root 2, Im by root 2, Vm by root 2, Im by root 2. So P equals to Vm by root 2 into Im by root 2. So here sin square theta can be written as 1 minus cos 2 theta by 2. Here 2 will get cancelled, so that Vm by root 2 into Im by root 2 minus Vm by root 2 into Im by root 2 into cos 2 omega t. So this is the instantaneous power. This is the instantaneous power. We can also derive the average power. So average power can be obtained by integrating the instantaneous power over a cycle. As we know that average power can be obtained by integrating the instantaneous power over a cycle. So average over a cycle, P average power equals to average of this term, constant term, plus cost term. So Vm Im by root 2 into Im by root 2 minus average of Vm by root 2 into Im by root 2 into cos 2 omega t. So as we know that the value of cos function for complete cycle for sinusoidal signal, cos function or sine function will be 0, as we have seen in previous class. While calculating the average value, RMS value, cos function and sine function will be for a sinusoidal signal. The entire cycle will be 0, so that remaining value will equals to this term only. So the average value of power equals to Vrms into Vm by root 2 can be written as Vrms. Im by root 2 can be written as Irms. So Vrms into Irms. So this term will become 0. So minus 0. So finally power P equals to Vrms into Irms. So Vrms is nothing but V equals to root mean square value of supply voltage. Irms is nothing but root mean square value of current. Hence the power in pure resistive circuit equals to P equals to Vi only. So the voltage and current in pure resistor circuit equals to in phase with the each other. That means there is no phase difference between the voltage and current. That means the phase angle equals to 0. So thank you.